Hey, welcome back to the second video of our hashtag remote rocks week one, talking about circles. So hopefully you were able to take a look at the first video. That was an overview and introduction to our circles that reviewed finding the area and the circumference of your circles. If you haven't taken a look at that video, please go back, watch that first, because again, we need to know how to do that stuff before we can move on. But if you are ready to go, we will jump into our new standards, which, okay, remember we're looking at determining the area of a sector and determining the length of an arc. So for this video, we are looking at this first guy, determine the area of a sector. Okay, now in order to do that, let's throw this back to our probability, what we ended up before we took a nice little break. So we have the spinner. We've seen the spinner before. We want to know what is the probability that this spinner will land on blue. Now, we asked this question in class, and everybody was able to see, okay, well, we have our blue section here, which is 60 degrees. Now, we know out of the whole circle, if we add all those up, we know that, yes, there are 360 degrees in this whole circle. So to find that probability, remember, we would take 60 over 360. Right, so I could keep that as a fraction. I know these zeros would cancel out. 6 over 36, that reduces to 1/6. So we have 1/6 of this whole circle, which if we calculate that as a percentage, that comes out to be approximately a 16.7%. Okay. Now, again, that was our last standard, but this has a big idea in it that will apply to our circles. Because if we think about the spinner, what we're actually comparing is we're looking at the area of this blue section versus the area of the whole circle. Now, we know we're just looking at a percentage of it, so we didn't actually need to find the area per se. But what if we did want to find the area? Well, that is what we're actually looking at in this video. Right? This little slice of the pie here that is just blue, that is what we call a sector. And that's what we're looking at here. So a sector, it's a region of a circle bounded by a central angle and an intercepted arc. I like to think of this as a pizza slice, right? So I have this circle here. Now, when we say a central angle, that is this angle here. Now, remember, an angle is made up of two sides. So that would be this side and this side, which in this case, in all cases, will be radius or radii. And then it's also bounded by the intercepted arc. So this arc of the circle, so the inside part here is what we call the sector. So now, our goal here is to find the area of that sector. And why would we want to do that? Well, if we think about some real life examples of sectors that we see, okay, if you've ever flown over the middle part of the United States, I was flying in a plane and I looked down and I saw all these circles, and I was wondering, what were they? Well, I actually researched, and they are fields, they're farms. And the reason why they're circular is because the sprinkler or the water system is in the center. And so then if you have a sprinkler, it's able to shoot at a radius, and then it creates a circle. And so we're thinking, okay, well, what if we want to figure out how much water we need for just parts of that circle? Well, if you look here, this little Pac-Man shape, this is actually a sector. Okay, it's a slice or a part of your circle. Okay, you could also think of a sector. This is the softball field at Kauffman. So this is a sector. And then here in any neighborhood, if you think of a court, if you think about the property, it can be represented by a sector. So there's a lot of sectors in everyday life, and it's very useful to be able to find the area of each one. So then looking at the area of that sector. So let's think about this spinner. If the spinner has a radius of 3 inches, I want to determine the area of that blue sector. Again, so I'm looking at this guy. It has a radius of 3 inches. And remember, that's on both sides. Okay. So then how would I find the area? Well, let's recall, how do I find the area of this circle? Okay, so the area of just the circle, remember that's pi times r squared. Okay, in this case, the radius is 3, so I can just plop in a 3 there. Okay. Now, we don't want the whole circle, we just want that portion of the circle. Now, the question here is, what portion of the circle is that? What fraction? Well, that's why we did this problem, because we figured out that fraction was 60 over 360, right? Or 1/6. That's the fraction of the circle I'm looking for. So let's say that we were looking at 1/2 of the circle. Well, I would take this and I would multiply by 1/2. Or if I was looking at 1/4 of the circle, I would take this multiplied by 1/4. Well, in this case, I'm looking at 60 3/60ths. So I take 60 over 360 and I multiply that by my pi r squared. Okay, so then let's go ahead, let's simplify this. So 1/6 times pi, remember that exponent first, so 9. Okay. And then again, when we're dealing with this, let's go ahead and deal with the numbers first. So then I have 9 over 6 times pi. Well, 9 over 6, that reduces to both divisible by 3. So 3 over 2 times pi, or 3 pi over, 3 pi over 2. Now that is in this case, inches squared. Now again, that is what we call our exact answer. It's in terms of pi. Okay, and also 3 over 2 we know would be a decimal, so we want to keep that as a nice looking fraction as well. Okay, recall that if I type in pi now, then it will give me a never-ending decimal. It will eventually be approximate. So if I'm looking for the exact, remember this is your exact answer. Right. Now I could plop that on my calculator. I type 3 times our pi button, remember use the pi button instead of 3.14, and divide that by 2, and that comes out to be approximately 4.71 square inches. Okay. So that would be the area of that blue sector. So let's go ahead and change this to the area of just the pizza slice. Okay. All right, so now let's take a look at this guy. So if we think about that equation that we just came up with and we used, we could formulate this general formula. So the area of a sector is equal to m over 360 times pi r squared. If we break this down, remember pi r squared is just the area of the whole circle. Okay? And then this fraction, m over 360, that is how we figure out what portion or what fraction of the circle. This is where m is equal to that, what we call the central angle. Okay, what angle inside are we looking at? All right, so now if I want to determine the area of this sector, now we call or name the sectors by the points that are on that sector. So in this case, sector AOB. Okay, I could also name this sector BOA. They're one and the same, but I want to find the area. So now if I do this, I'm going to do this 2 ways. Okay, so if I use this area formula, so I have area equals m, which would be 70 in this case, over 360, times pi, and our radius in this case is 18 squared. Okay. Now, in this case, if I look at 70 over 360, that's not going to come out to be nice and neat. 18 squared, that's going to be a big number. So in this case, I'm just going to go ahead and get an approximate answer. So I know zeros are going to cancel out. 7 over 360 times pi, and then 18 squared is 324. Okay. I would suggest at least break it down to there, and now I could plop things into my calculator. So this is approximately, if I do 7 over, oh, should have taken away that 0, sorry, over 36 times pi times 324. Our answer here is approximately 197.92, and this is centimeters squared, remember area. Okay, so that's one way or one method of doing this. Let me show you a second method. Okay, and this is a method that Mr. Sutherland likes to use, thinking about proportions. So we're thinking sector to the whole circle. So we're setting up a proportion sector to the whole, or part to whole. So if I think about the degrees, so that's 70 to 360. That should be equal to, well, the area of this sector, which is what we're trying to find, let's call that x, over the area of the whole circle. Well, that's pi times 18 squared. So you could set up your proportion, and then we know, okay, if I have fraction equals fraction, then I cross multiply, right? And so then I have, if I type this in, 70 times pi times 18 squared, that's going to give me a big number, okay? 71251.32, but that's equal to 360 times x. Okay. Now, in order to solve that, then I divide by 360, and I end up with the same answer, 197.92. So 2 different ways you can think about it. Now, if you really analyze these, then essentially it's the same thing, and it's actually how we end up with our first equation. If you look at here, if you solve for x, then all you do is take this guy and you multiply it over, which is just our 70 over 360 times pi times 18 squared. So they're essentially the same equation, just a different way of looking at it. So you pick which way works best for you and run with that. Okay. All right, so let's take a look at this guy. So area of this sector, Anya is painting a wall clock. The clock will have a diameter of 3 feet. What is the area of each sector to the nearest hundredth? So in this case, we're thinking, okay, how much paint do I need for each of these sections? So then if she's getting different colors, she can approximate how much paint she needs for the whole thing. All right, so let's think about here. Now, what are we missing here? Well, we're missing the angle, right? So we need to know what is the angle of each of these pieces. Well, they're all equal, so there's 12 sections. So to get that angle, then I could do 360 divided by 12. Okay, well, 360 divided by 12, that gives me an angle of 30 degrees. So then I know, okay, each section is 30 degrees. That is my central angle. So then if I plug this in, my area, remember 30 over 360 times my pi times my, what did I almost do wrong? This has a diameter of 3 feet. So what is the radius? The radius is 1.5, right? So I type 1.5 squared. Okay, so again, let's just go ahead and approximate this. We know zeros will cancel out, so then this comes out at 1/12. Okay, so then I take 1 divided by 12 times pi times 1.5 squared, and I end up with 0.589, okay, which then, if we think about this, would round to 0.59 feet squared, which if we think each section, it's rather small, so that makes sense. Okay, so that is that question. Let's look at one more example here. Now, if you recall the last video, at the very end, we talked about I could always work backwards. Well, in this case, I could work backwards as well. All right, so if I have this guy, it says if the area of sector AOB is 235.5 millimeters squared, what is the length of the radius of circle O? So in this case, it gives us the quote unquote answer. This has 23 or 235.5 millimeters squared, right? And I need to work backwards. So let's think about, again, let's look at this two different ways. Okay, first way we'll use our equation. Our area equals our m over 360 times pi r squared. Now, what is our m in this case? Our m is 120, right? So then I'm looking for r. Well, what else do we know? We know the area, so I could take area and I could take 235.5, all right? And I could then solve for my r. Remember, I want to get r squared by itself. So I'm going to multiply each side by 360, so 235.5 times 360, and then I'm going to divide by 120. And then I need to also divide by pi. So then I end up with r squared is equal to 224.89. And then how do I get the r by itself? I take the square root of both sides. So I type that in my calculator, and I get 14.996. So r is 15 millimeters. Okay. Now let's look at it a different way. Again, kind of the way that Mr. Sutherland likes to look at these are proportions. So I have the part to the whole. So my part would be 120 to 360, and my whole would be my area of the sector, 235.5, to the area of the circle, which is pi times r squared. Okay, so again, I could cross multiply here. So then I have 120 times pi r squared, and then I have 235.5 times 360, and I get 84780. Divide by 120, also divide by pi, and then I end up with r squared is equal to 224.89, which, hey, look at that guy. So then I end up with r is equal to 15 millimeters. Okay, so I could work backwards as well. So what that takes us to is finding the length of an arc, which we'll take a look at the next video. But if you have any questions, again, hop on to Schoology, and then get a hold of us in our office hours. Remember, 9:30 to 10:30 with Mr. Sutherland, 1:30 to 2:30 with me. Now, if you feel like you're ready, again, you can hop on to the next video and we will talk about the length of an arc.